Hello everyone, my name is Abhishek and welcome back to my channel. So today is day 34 of our complete DevOps course. Congratulations, we already reached day 34 of 45 days DevOps journey. And in this class, we'll be talking about Kubernetes deployment. So from classes day 30 to 33, we try to understand in depth about the Kubernetes architecture, how is it compared with Docker, Kubernetes installations on premise as well as cloud. And today on day 34, we will be learning about the Kubernetes deployment. So what is this Kubernetes deployment? To understand that, everyone must have watched the previous video, that is day 33. It is very important because we talked about Kubernetes pods. So let's try to understand the difference here itself, right? If Kubernetes can do things with pod, okay, so if you can deploy your application onto Kubernetes as pod, then why do you require deployment? Okay, so what is the comparison that we are going to look at? The difference between a container, a pod, and a deployment, right? So this is your interview question as well. So people will ask you in an interview, what is the difference between a container, pod, and a deployment? You might feel this is a very entry level question, but if you can't answer this question, then there itself your interviewer will understand that you don't have experience on Kubernetes. So basically containers, like we have watched from day 23 to day 30, you can create containers using any container platforms. Like let's say you have created a container using Docker. Okay, so to run this container, what you usually do is you provide the specifications to run this container on the command line, right? So how do you do that? Basically, you say docker run -it, right, or -d if you want to run in the detached mode, then followed by the name of the image. Then if there is any port, you will expose using -p. If there is any volume, you will use -v. If there is any network, you will use hyphen network. So similarly, you will pass bunch of options here, right? So this is how container works, and this is how I'm not going into the workflow, how you create a container. You write Docker file, build Docker image and container. Let's not go there, but just let's assume that this is how you run a container on Docker platform. So what Kubernetes said is, okay, let me modify this process and let me bring a enterprise model to this. So what does Kubernetes say is, instead of writing all of these things in the command line, you can create a YAML manifest. Okay, and inside this YAML manifest, you can define all of these things that you are defining here in the command line option. And you can just say what are the things that are required, what is the container image, right? Even you provide the container image here. Then what is the port that you want to run this specific container on, what is the volumes that you have, and what is the network. So everything you can provide in the YAML manifest. So a pod.yaml or a pod YAML manifest is nothing but a running specification of your Kubernetes Docker container, right? So it's just like a running specification. What are the parameters that you require to run a container is pod. So the only difference here is a pod can be a single or multiple containers. Okay, so in a pod you can create a single container or multiple container. Why do you create multiple containers? Is because let's say you have an application that is dependent on other application without which it cannot run. Or you have a container here. This is your actual application container, and in this you have written your API gateway rules, your load balancing rules, like sidecar containers. So in such cases also you can put both of them inside a single pod. So a popular use case is service mesh. So in case of service mesh, you have a container that is sidecar container, and this is your actual container. So what is the advantage is, if you use a pod, now both of them can share the same networking. So both of them can communicate using localhost, and both of them can have the same volume or storage kind of things. Okay, so this is about the pod. Now, finally, what is a deployment? So if you can ask me this question, Abhishek, in day 33, we already saw how to create a pod, how to deploy a application using a pod. We deployed an Nginx application. Now, why we have to transition from pod to a deployment? Because if you can deploy a container, or if you can deploy an application as a container in Kubernetes using a pod, what is the purpose of using a deployment? This is a very valid question, right? So your interviewer can also ask you this question. So to answer this question, it is very simple. So Kubernetes, like I always told you from day 23 or from day 30 when we started learning Kubernetes, Kubernetes offers you some things which is required, which is the requirement for people to move from container platforms like Docker to Kubernetes. What are the two important things that I told you? The first thing that I told you is the auto healing behavior. The second thing that I told you is auto scaling behavior. Okay. So does pod has this capability of implementing auto healing and auto scaling? No. So pod is equivalent, not equivalent, is somewhere similar to your container, because a pod is doing nothing. It is just providing a YAML specification of running your container, nothing more than that. Or in some cases, a pod can run multiple containers and it can offer some advantage there, because these two containers can share networking and share the storage space. But the thing that pod cannot do, and which is very important, is the auto healing and auto scaling capability. So who offers these things in Kubernetes? This kind of things in Kubernetes can done using deployment. Okay, so if you want to do some zero downtime deployments, or if you want to bring in auto healing, auto scaling, then you should never deploy your applications as pods in Kubernetes, but instead you should deploy as deployment. And what deployment will do, end of the day, it will deploy a pod only. Okay, but instead of deploying a pod, if you deploy a deployment, what it does is, let's say you have deployed this deployment. Okay, you have created a deployment resource. It will again create some intermediate resource called replica set, and then replica set will create something called as pod. For now, forget about this replica set, because I'll teach you as we progress into the video. But so this is how you can create pod. So the practice that you have to do is, or what Kubernetes suggests you is, do not create pod directly. Okay. So end of the day, you will be creating pod only. That's why we saw in day 33 how to create a pod, what is a pod, all of those things. You have to know the concept, but do not create it directly, but create it using a deployment resource. Okay. So what is this resource called? Deployment resource. And what this deployment resource will do is, firstly, it will create something called as a replica set, which is your Kubernetes controller. Okay, what is this? This is a Kubernetes controller. And then what happens is, this will roll out your pods. Okay. Now, why you need this intermediate resource? So the thing is, what a deployment does is, inside your deployment, you can just say, what is the number of replicas of your pod that you require? Okay. So why is this required is, in some cases, you always do not want to have a single replica of your container. Sometimes your load will be too high. You might want to expose your application to multiple concurrent users who can access your applications. Like, you can say 100 users should go to pod 1, 100 users should go to pod 2. I mean, a replica of pod, replica 1 of pod and replica 2 of pod. That means to say, you are implementing, you can call it as high availability or load balancing, or whatever is a general terminology. Okay. So what you can do inside your deployment YAML manifest, deployment is again a YAML manifest, because in Kubernetes, everything is a YAML manifest. Okay. So inside your deployment YAML manifest, you can just say replica count as 2. But when you say this, okay, there has to be something in Kubernetes that ensures that, okay, you said I want 2 replicas. Okay, so deployment will create a pod, that I have already told you. But if we go back to the topics called auto healing and auto scaling, okay, what does auto healing mean? If you say you need 2 replicas, okay, deployment will create using ReplicaSet two pods. But what ReplicaSet additionally does is, because it's a Kubernetes controller, what it will always do is, it will ensure that there are 2 controllers, even if some user deletes one of these pods. Okay, sorry, there are 2 pods. So even if a user deletes one of these pods, he says that, okay, accidentally I deleted one pod, now there is only one pod. Kubernetes will say, don't worry, because you have submitted a deployment YAML manifest to me, I implement auto healing using this replica set controller. Okay, so it will always ensure that there is 2 number of replicas on the controller. If you are not understanding this, wait for the demo. In the demo, live I'll show you how this is working. Okay, so the end process is, you will create a deployment. Okay, and this deployment will roll out a replica set, okay, which is called as RS. And this will create the number of pods that you have mentioned in the deployment YAML manifest. Okay, what this RS or replica set will do is, it will ensure that what user has provided in the YAML manifest, it will ensure to be implement the auto healing capability. If you say the replica count as 2, if you can say the replica count as 100, this replica set will always ensure that there are 100 replicas of your pod on the Kubernetes cluster, so that million users can parallelly use it maybe. Okay, so if user deletes one and if he makes it 99, what replica set will do is no, because deployment told me that the pod count has to be 100, so let me put it back to 100. Okay, so this is how a zero downtime deployment. Or tomorrow, let's say you want to increase the replica count from 100 to 150. Okay, you can just go to this YAML manifest and change the replica count from 100 to 150. I'll show you how does the deployment YAML look like. But for now, if you change the replica count from 100 to 150, then RS will say that, oh, okay, there is a new change in the YAML manifest. So I have to increase the pod count from 100 to 150. Let me create 50 more pods. Okay. 50 more pods in the sense 50 more replicas of your pod. Okay, so this is how a deployment works. It will create a replica set, and this replica sets will create a pod for you. Okay, and this replica set is a Kubernetes controller. So if you are listening this word for the first time, Kubernetes controller, don't worry, you will get acquainted with this, because in Kubernetes we deal with a lot of controllers. So controllers are something which maintains a state. It always ensures that the desired state is always present on the actual cluster. That means desired state and the actual state on the cluster are same. So anything that is doing this behavior in Kubernetes is called a controller. Okay, so there are some default controllers in Kubernetes, and you can also create custom controllers like Argo CD, admission controllers. All of these are custom controllers that you are creating. Whereas the default controllers are also available in Kubernetes, which ensures that the actual state is always same as the desired state. Okay, so whenever you hear this term called controller, just understand, okay, controller is something that will ensure that the state in the YAML manifest, if in YAML manifest you are saying something has to be there, it is always there in the Kubernetes cluster that is maintained by the controllers in Kubernetes. Okay, now this is the introduction. So the popular interview questions here will be, what is the difference between pod versus container versus deployment? So this is question number one. If you are not able to answer, go back and watch this specific slide. Okay, so here in this slide I clearly explained container versus pod versus deployment. Okay, so this is question number one, and the question number two will be, what is the difference between deployment and replica set? So people will confuse here. Don't worry, it's very simple. So replica set is basically a Kubernetes controller. That is the one that is implementing the auto healing feature of your pods. If a pod is getting killed, or if a deployment says that increase the pod by one, so who is doing this? Replica set controller. So replica set controller is the one which is actually implementing the auto healing capability by saying that the actual state in the deployment YAML manifest, or the actual state in the deployment, should be on the cluster. Okay, so this is the desired state that is provided in the YAML manifest, which always have to be same on the actual state. So when you create a deployment, a replica set is created automatically, which is responsible for tracking this controller behavior in Kubernetes. Okay, so this is it. Now let us try to see this in practical, and don't get confused. It's a very simple topic. Even if you refer to the Kubernetes documentation, you can learn about deployments in 30 minutes, not more than that. Okay, so let me stop this here and let me share the screen. Stop. Now let's take a terminal and let's try to implement this live. So share screen. Perfect. Let's say I'm new to Kubernetes. Okay, and I don't know anything. Only thing that I know is from the last classes, if you use kubectl command, you can interact with the Kubernetes. Okay, so you just have created a Kubernetes cluster. It can be Minikube cluster, or it can be the clusters on AWS using kops that I showed you. Okay, Minikube also we have seen, it's very simple to create. So I'm assuming all of you have a Kubernetes cluster and kubectl configured. Now if I do kubectl get pods, okay, so at this point of time there is something, so let me delete it. Okay, so that the demo will be clear. So I have one deployment, and what I'll do using kubectl, I'll just delete it, so that we are ready for our demo. Kubectl delete deploy this specific thing. Now if you notice, kubectl get pods, there are no pods. kubectl get deploy, there are no deployments. So in real world scenarios, you cannot do all of the, like, you cannot enter multiple commands. So you can just say kubectl get all. So it will list everything, like the get deployments, pods, services, all the Kubernetes by default services. It will list out in the particular namespace. Okay, perfect. So this is one interview question again. If somebody asks you how do you list out all the resources that are available in a particular namespace, you can just say kubectl get all. And if you want for all the namespaces, just say kubectl get all minus a. Then it will list out for all the namespaces, all the applications in your cluster. Okay, but for now, just because I was doing that command, I just thought of explaining you. If you go back to the specific course of today, we will see what will happen to Kubernetes pods because we stopped from there. So I have a pod.yaml. Let me open this pod.yaml. This is the same thing that we saw in the last class. Okay, so what is it? Just a Kubernetes pod, simple Kubernetes pod. This is the example that we have copied from the Kubernetes documentation. Okay, and what is it doing? There is a simple nginx image, and let us try to create it. How do you create it? Kubectl apply -f pod.yaml. Now what happens as soon as we apply it? This will be created on your Kubernetes cluster. Let us see if it got created. Kubectl get pods. Awesome, it got created. How do we check the IP address of this? Just say -o wide, so it will print. Kubectl get pods will just give you some information, and if you do kubectl get pods -o wide, it will give all the information about the pod. Okay, or you can also give kubectl describe. Anything is possible. So kubectl get pods -o wide, where you got the IP address of this. So what I'll do is, to access this pod, I need to log into my Kubernetes cluster. So because my Kubernetes cluster is Minikube, so Minikube just says enter this command called Minikube SSH. But if you are using a remote Kubernetes cluster, you have to use SSH -i, your identity file, right? Followed by the name or the node name or the IP address of the node, so that you log into your Kubernetes cluster. But because Minikube makes our life easy for development, it just says that enter Minikube SSH, and we will convert the command accordingly, and you will log into the Kubernetes cluster. So now just say curl, and this specific thing, your application is running. This is something that we saw in the last class as well. Now I'll show you something that will make you understand why deployments are required. The same thing that I explained in the theory as well. Just say kubectl delete pod. What was the name of the pod? Sorry, I forgot. Kubectl get pods. Okay, let me copy this. Kubectl delete pod nginx. Let's say someone performed this action. Accidentally, someone deleted a pod on your cluster. So now when I click on the enter button, or let's say for some reason your pod got deleted because of some network issues, or for some reason your pod got deleted. Now the customer who is trying to access your application, usually customers won't access using Minikube SSH and all, because they are external people who are outside your Kubernetes cluster. So in future classes, when we learn about ingress, we learn about service, you will understand how that happens in real time. But for now, just assume, because we are still in the concept of pod, you have done Minikube SSH, and when you try to access the same application that we did, okay, so using the IP address, I think I forgot the IP address. Yeah, curl 172.17.0.3. Now you will notice that the application is not reachable because you have killed the pod. The application is gone. Now you should ask me, then what is the advantage of Kubernetes? Because the same thing was happening in Docker also. You told me that Kubernetes is a very robust platform. Kubernetes supports auto healing, auto scaling. Wait, so Kubernetes supports all of that, but you have to create the correct resource. You have created a pod. Instead, you have to create deployment. Okay. Now the next question will be, Abhishek, but this syntax is very huge. How do I remember all of these things? Don't worry, nobody remembers all of these things, and it is also not suggested to remember all of these things. What you need to do is just go to official Kubernetes documentation or any examples that you want to follow. You are open to follow any specific website. Just go to the deployments, and here you have an example. So in the future, if you want to deploy your application, you can simply modify this image here, right? And if your application has some volumes and specific thing, you can take example in the Kubernetes documentation itself. You have a lot of examples. I'll show you. You can pick the right examples, and then you can just update the fields which are required. Okay, so that is how you have to deal with it. Don't remember all of this syntax because it's waste of time. In your interview, nobody will ask you to write the syntax. People will ask you what is image in container, or what is the labels and selectors, what is the role of it, or what is the role of replicas. This is what people will ask you. Okay, so this is the same thing I have on my cluster as well. And if you see here, this is what I'm telling you. Inside deployment, what you will do is you will say how many pods you want to create. Do you want to create one pod? Do you want to create two pod? Do you want to create three pods? For example, I'll show you that I want to create only one pod for now. Now let us see what happens as soon as I create the deployment. Kubectl get, sorry, apply -f or create -f deployment.yaml. As soon as I do this, the deployment is created, but the magic is kubectl get deployment is there, but you'll also notice when you do kubectl get pods, pod is also created. So this is what I was telling you. So who has created this pod? Like I told you, the ecosystem is, once you create a deployment, it will create something called as a replica set for you, and replica set will create a pod for you. Okay, so we can see this same. If you do kubectl get deploy, you notice that the deployment is there. Then you do just say kubectl get rs, you will see that the replica set is also there. Rs is shortcut for replica set. Okay, and then when you do kubectl get pod, your pod is also created. Okay, but what is a deployment? Deployment is an abstraction. That means you don't have to create this replica set, you don't have to create this pod. What deployment says is, okay, just create one resource called deployment.yaml and I'll take care of everything for you, because I am responsible for implementing auto healing and zero downtime in Kubernetes. Okay, but deployment will not do it directly. Deployment will take help of ReplicaSet, and ReplicaSet is a Kubernetes controller which is actually doing it. What is a Kubernetes controller? Kubernetes controller is nothing but a Go language application that Kubernetes has written, which will ensure that a specific behavior is implemented. Now, in this case, what is the behavior? The behavior is that the desired state or the desired number of replicas inside the deployment has to be available on the cluster. I'll show you live. Let's take two terminals here. Okay, I took two terminals here and let us see it in live. Let me just say kubectl delete pod. This is the name of the pod, right? And before I click on enter, what I'll do is I'll watch for the pods. Kubectl get pods -w. When you do -w, that means you are watching. It will show you in live what is happening with the pods. So as soon as I click this button, you will notice that the pod is getting deleted. But see the magic. What is the magic that ReplicaSet is doing for you? Even before, like it initiated the terminating signal, but before the termination is done, it is just terminating, not terminated. Okay, so before the termination is done, what it has done is, a new container is getting created. That means a new pod is getting created, and you see both of the actions has taken place in parallel: terminating, running. That means the termination and the running are happening in parallel. If someone, there is a malicious user, let's say I am a malicious user or I am a wrong person who has deleted your pod, then even without your consent, replica set, because it knows that the deployment has told it that the desired replica count for the pod is 1, so it ensured that the pod is always in running state. Even if someone deletes it, there is one pod that is available. So if you just see kubectl get pods, you will notice the same behavior, right? So the pod is running. Now let me increase the pod count and show you. Just say vim deployment.yaml. Let me increase the pod count to 3. Okay. Now again, let me apply this manifest kubectl apply -f deployment.yaml. You can also use kubectl edit command, but apply is more easy. Okay, so that's why I just modify the YAML file here, and then I just use the apply command. So kubectl apply -f deployment.yaml. Now let us again watch for the pods. Kubectl get pods. What is the expectation here? The replica count should be increased by 3. And who has to do it? Replica set. Let us see if replica set is doing it. Configured. Now let us see what is going to happen. If you see here, there are 3 pods. Okay, now who has created these 3 pods? Again, replica set. So deployment is just a wrapper. It's just a high level abstraction. Deployment by default will not do anything for you. It's just like a high level abstraction. And who does the things for you? Replica set controller. Okay, now let me delete one of the pods and let us see what happens. Okay, kubectl get pods. So there are 3 pods, right? Let me delete one of these pods randomly. And again, what replica set has to do is it has to make sure that 3 pods are running, irrespective of the one pod that you are deleting, 2 pods you are deleting. It always has to ensure 3 pods are running, because it's a Kubernetes controller that is responsible for keeping a state. That is a Kubernetes controller that is responsible for auto healing. Let me click enter. Now let me see. Is the pod deleted? Okay, I just said get. Sorry, I have to do the delete operation. I was just confused why Kubernetes is not showing anything. Yeah, delete a pod, and now let us see what is going to happen. See, again the behavior is the same. Even before deleting or parallelly, deletion and creation has happened. So that's what is the beauty of Kubernetes. If you say kubectl get pods, you will see that the 3 pods are running. Awesome, right? So this is how Kubernetes implements the auto healing capability using deployment, replica set, and pod. Okay, so in real world Kubernetes or in production scenarios, you will never create a pod directly, but what you will do is you will create a deployment. Okay, so this deployment will create replica set for you, and replica set will create a pod for you. Okay, so this is how Kubernetes will work in real time. So your assignment for today will be create a deployment. Okay, so take the same example, replace your image. Okay, so here replace your image and play with the Kubernetes like I showed you. Okay, kill a pod and see what is going to happen. Create new one, increase the replicas, and see if replica sets are getting created or not. Okay, so if you see here kubectl get rs, this is the replica set you have not created, but replica set is automatically getting created, right? And that is creating pods for you. So understand this behavior, keep playing with it. Okay, take more examples of deployments. You can just search for, just come here randomly, Kubernetes deployment examples. Okay, and just search for GitHub. You'll notice bunch of Kubernetes examples. Okay, this is official Kubernetes repository, and you have bunch of examples here. Just take guestbook example. Okay, and choose any of the thing that you want, all in one, for example, where you have the this one here, I guess, all-in-one.yaml, and here you have a deployment. So you can find bunch of examples in the internet. Okay, just play around with these examples, because this is what you will do in real time as well. On a day-to-day basis, you will not create pods, but you will create deployments. Okay, whether you are creating these deployments directly or you will put it in the Git, so those are in the future. But now you have to understand this concept, how Kubernetes does zero time deployment. What is zero time deployment? If you see here, I increased the replica count from 1 to 3, but it happened without disturbing the existing pod. Even I deleted one pod. Okay, then it did not disturb the existing application. No live traffic is destroyed because parallel creation and deletion has taken place. So user will not face any disturbance. Okay, of course there is role of service, there is role of ingress, which we are going to learn in the future. But till this point, you have to be clear with the concept. And I hope you enjoy the video. If you like the video, click on the like button. If you have any questions, put the timestamp and ask the question to me. Then if you feel there is someone who is going to be benefited by these videos, please share the videos. Thank you so much. I'll see you in the next video. Take care, everyone.